Security baselines for AI workloads in Azure will help ensure that AI models, data, and infrastructures are protected throughout the AI lifecycle, from data ingestion to model deployment. Since AI workloads involve sensitive data, complex models, and powerful computing resources, they require a tailored approach to security. Let's unpack how Azure services, tools, and best practices provide a secure environment for AI workload. You need to ensure that data used by AI model training and inference is protected. As a practice, encrypt data both at rest and in transit using Azure Storage Encryption and TLS. Azure services such as Azure Data Lake, Azure Blob Storage, and Azure SQL Database provide built-in encryption. Implement fine-grained access controls to restrict data access. Use role-based access control and Entra ID to control who can access datasets and where they can be accessed from. You should also use data masking and anonymization techniques to protect sensitive data in dataset used for training. This can be done using Microsoft Purview to classify and label sensitive information automatically. For highly sensitive data, leverage Azure Confidential Computing, which provides a trusted execution environment to securely process data in memory. When it comes to model security, you should secure AI models to prevent unauthorized access and tampering. As a practice, store models in Azure Machine Learning Model Registry with version control to track changes and ensure integrity. Use RBAC to restrict access to models only to authorized users. Encrypt AI models both at rest and during transmission. Azure ML allows for model storage encryption and ensure models are safe from unauthorized access. When deploying models, use Azure Kubernetes Service or Azure Container Instances with network security controls to secure the inference environment. Use private endpoints to restrict access to only internal networks. And leverage threat detection features to detect adversarial attacks against the AI models. When it comes to compute environment security, you should protect the compute resources used for training and inferencing AI models. As a practice, use dedicated compute resources such as Azure Dedicated Host or confidential virtual machines to provide isolation for sensitive AI workloads. Use Azure Virtual Network Integration for services like Azure ML and AKS to ensure that data and compute resources are not accessible from the public internet. Control access to compute environments using Entra ID and manage identities, and ensure that only authorized users and applications have access to AI resources. Enable Microsoft Defender for Cloud to continuously monitor compute resources for potential threats, suspicious activities, and security vulnerabilities. For identity and access management, as a practice, as usual, use Entra ID and RBAC to grant the least privilege required roles to the users and applications. Define roles specifically for data scientists, developers, and administrators with the necessary access level. Use managed identities for Azure resources to provide secure, passwordless access to Azure services and reduce the need for hard-coded secrets in AI scripts. Enforce MAP for accounts that have access to AI workloads, especially for accounts with elevated privileges, and use conditional access policies in Entra ID to enforce location, device, or risk-based access conditions for sensitive AI resources. For monitoring and logging, you should enable visibility and accountability for activities on AI resources. Use Azure Monitor and Log Analytics to track resource utilization, errors, and performance of AI models in production. Configure logs for Azure ML, AKS, and data storage services. Enable audit logs for Azure resources to record all access and modification actions on data and AI models, which help identify unauthorized access attempts. Configure alerts for unusual activities such as high compute usage or access from unapproved locations. Integrate with Microsoft Sentinel for incident response and automated remediation. Monitor models in production for drift and performance degradation, which could indicate potential data poisoning or other security concerns. For data and model privacy compliance, you should ensure that AI workloads comply with data privacy regulations such as GDPR, CCPA. As a practice, use Microsoft Purview to track data lineage, classify sensitive data, and ensure compliance with regulatory standard. Minimize data collection to what is necessary for training, and use data lifecycle management to define the retention policies for sensitive data. For supply chain security, you should secure dependencies, libraries, and models sourced from external vendors or open source communities. Use Azure DevOps or GitHub Advanced Security to scan code dependencies for vulnerabilities. This helps identify insecure libraries and frameworks that could impact AI models. For models sourced externally, validate and test them within a control environment before deploying to production. Track data and model lineage with Azure ML, ensuring that you have visibility into all data sources and dependencies involved in the model lifecycle. Overall, security baselines for AI workloads in Azure will help protect data, models, and compute resources against unauthorized access, misuse, and regulatory non-compliance. By following these best practices and leveraging Azure native security tools, administrators can maintain a robust security posture for their AI workload and ensure the confidentiality, integrity, and availability of AI applications. This approach not only safeguards sensitive data and models but also enhances trust in AI systems by ensuring they are compliant, transparent, and secure.